Hi, this is Roberto and I'm going to teach you physics. I started this video and somehow and the battery died, so I don't know if I can use part of the previous video. Anyway, I'll start again. So I'm going to do an experiment that was carried out centuries ago, not in this form, probably because I invented this way of putting it. An experiment was carried out by Newton. Newton worked in mechanics, dynamics, optics, and also in fluids. Okay, what we call rheology, the study of fluids moving. So, I have two trays. The neighbors are cooking French fries or chips. Nice. So, in these two trays, I'm doing this experiment in my kitchen for obvious reasons, because this tray is full of water, you see, full with some water. Okay, how you can see it from there's water, right? And this other tray, water in one, and the other has some soap. It doesn't have nothing to do it. Quite nice because it's violet. Okay, violet. Also in color. Okay, so as you can see, it's thicker. You see by how it behaves, that sticks to my finger. So it's thicker. And I prepared this Porexpan trays. Porexpan, show to you what it is. Comes from a tray of endives. I think you pronounce it endives. Or endives, something like that. Okay? Porexpan, these are my favorite salad, vegetable for salad. So Porexpan is a plastic, everything for science. Science got me on my knees. So with air inside, trapped inside, so it's very light. So what I'm going to do is the Porexpan shape I prepared. I attach a string, okay, and I'm going to pull to see if there's a difference. You see the soap slowly floating or flowing. So, okay, comparing in water and in soap. As you can see, I have to make a force to move it, to move the solid. Why? Because it has to move the fluid underneath. And if the fluid is viscous, it's more viscous, as in this case I have to pull a stronger force. Okay? This force depends on another factor. I cut, that's my girlfriend texting me. Hold on, real life. Hold on, hope you don't mind. Oh. Yeah, Sunny, you want to see? No, I'm not showing you. I'm too shy. You wanted to see, right? Okay. So, she's okay, and that's the important thing. She just drove for an hour. So she sent me a message to tell me that she was okay. So, another depends on another factor besides the viscosity. So I prepared a shape which is double in surface, okay, double in size, and I'm going to see if there's a difference when pulling the string. Okay, so this is my reference, quite hard, and this is like it's stuck, you know. I have to apply some force, but here I have to apply a lot of force. So surface also affects in the force I need to move a solid on top of a fluid. In other words, to move a fluid. So we have one viscosity, this is not thick and this is thick. Surface, the bigger the surface, the bigger the force, the bigger the viscosity, the bigger the force. And there's another factor, is the moving of, you know, how water moves in the bath. So see, compare this with this. Okay, see? Hope you can see from the video. If I do this, I'm moving much more water, so I have to apply a force. And shapes in navigation, this is called the wake. So it's the water that a ship agitates behind its, I don't know, what's the word? Behind it. Okay? So 3 factors influence the force we need to apply to move a fluid. The viscosity of the fluid, the surface we are moving of the fluid, surface, and the wake, the amount of water we move. Okay, all these affect directly to the force. That's what Newton's experiment is about. Now I'm going to the blackboard to see it with an equation. Okay.